Now that we have practiced with some different types of factoring, mainly the simple trinomial factoring and difference of squares, we are going to look at multi-step factoring. Okay, so I touched on this a little bit in the last example of the difference of squares video. But if we have a trinomial like this one, we want to take a look at how we can factor that. Okay, so from looking at it, we know that we can't use the simple trinomial factoring method because the key thing with that method was there had to be no number in front of the x squared. Okay, there needed to be an a value of 1, which in this case there is not. So we cannot start with the simple trinomial factoring method. However, what we might notice is that all of these numbers, we've got 2, 14, and 24, they are all divisible by 2. Okay, so the first step is we are going to common factor. This is always going to be our first step, is checking if there's a common factor and removing it before moving on to the next type of factoring. Okay, so like I said, in this case, there's a common factor of 2. So I'm going to factor that out. I'll have the 2 in front. Okay, that's what we do with common factoring. And then because I started with 3 terms, I will have 3 terms in the bracket. Okay, so 2x squared divided by 2 is just x squared. Okay, and remember that the numbers only interact with numbers. Okay, the x squared and the x just stay the same. So 14 divided by 2 is 7, and the x stays there. And then 24 divided by 2 is 12. Okay, so we cannot factor out an x. That's something that's common that people try to do, is they try to factor out 2x, but we can't do that because there's no x on the last term here, right? And there wasn't to begin with either. So we cannot factor something out if it doesn't exist in that term in the first place. So it's just a number that we are common factoring. Okay, and what I want to specify here as well, so we're factoring out the a value. Okay, so right in this case, the a value on my equation was 2, and that's what I factored out. Now I have, inside my bracket, I have a simple trinomial. So then I am going to factor the trinomial in the bracket. So similar to what we looked at yesterday, I'm looking for 2 numbers that multiply to give me positive 12 and add to give me positive 7. Okay, they're multiplying to the c value, adding to the b value. So with 12, you can kind of go through the factors in your head. So we would have 1 and 12, 2 and 6, 3 and 4. Both numbers here are positive, so like I've got positive 7 and positive 12, which means that both my factors have to be positive. So I'm just doing a quick check here with my pairs of factors. So 1 plus 12 is 13, that's not right. 2 plus 6 is 8, that's not right. 3 plus 4 is 7, that is right. Okay, so those are going to be my 2 factors. Right, I've got 3 times 4 is 12. 3 plus 4 is 7. So my fully factored form would look like this then. 2x plus 3, x plus 4, and now that is fully factored. Okay, so it looks the same as the factored form we had yesterday. The only difference is that you'll have a number in front here, and it's going to be the same number as your a value in the original equation. And same as yesterday as well, it doesn't matter what order these brackets are in. Okay, you could have x plus 4 first and then x plus 3. It doesn't matter because multiplication is what we call commutative, meaning you can switch the terms around and it will not change the outcome or the product of it. So when we are doing this type of factoring, multi-step, where we are common factoring first and then doing the simple trinomial factoring, what we need to keep an eye out for is that the a value needs to be this, a factor of all 3 terms. Okay, so all 3 terms must be divisible by a. Okay, so in that first example, they were all divisible by 2. Okay, so this is asking for an example where a is 2 that wouldn't work. Okay, so if we had, let's say, like 2x squared minus 5x plus 17. Okay, if we were to look at this, we want to check and see, can we divide all three terms by a? Obviously, you can divide the first term by a, but -5 does not divide by 2 nicely. Okay, so without a fraction or decimal answer. So although like 2, it's still relatively nice, right? You would get -2.5, which is not like awful in terms of a decimal. You only can use it as a common factor if you get a whole number when you divide it. Okay, so -5 does not divide evenly by 2, and neither does 17. So we would not be able to use this multi-step factoring because we cannot common factor first. Okay, so this is an example of one that would not work. Whereas an example of one that would work is, let's say if I had 4x squared minus 36x plus 100. I know that all three of those terms are evenly divisible by 4, so that's an example that would work. Okay, so that's the only thing that you need to keep an eye out for, is that all of your terms can be divisible by your a value. So I'm going to do one more example here of fully factoring this quadratic. And when I say fully factor, that's usually indicating that there is multiple steps. Okay, so I've got -3x squared minus 9x plus 12. So I'm looking at what my a value is. In this case, it's -3. Okay, it's important that it's -3 because, well, I'll show you why in a second. So we want to see if I can divide all three terms by -3. Okay, so I would divide by -3 here, here, and here, and we can see 9 and 12 are divisible by 3, so that is going to work out fine for us. So we would then have y equals -3, and the reason why it's important that we're dividing by -3 is because I want that first term to be just x squared left over. If I divided by +3, then I would have -x squared in the bracket, and that is not something that we want, okay? It needs to be just a +1 in front of your x squared term, okay? So then -9 divided by -3 is +3, and +12 divided by -3 is -4. Okay, so that's my first step, is dividing everything by my a value. Then I am going to use my simple trinomial factoring. Okay, so I'm looking for two numbers that will multiply to give me -4 and add to give me +3. Okay, so if I think about my factors of 4, I have 1 and 4, 2 and 2. Okay, so one of them would have to be negative, right? Because it's multiplying to -4, so I could have -1, +4, or I could have +1, -4, and then I could have, it would be -2 and 2. There's not really a second option for that. Okay, so it's not going to be -2 and 2, because if I add those, that's 0. It's going to be these two, right? Because if I have -1 multiplied by 4, that would give me -4. And then -1 plus 4 gives me +3. Okay, so my fully factored version of this equation would be y equals -3x minus 1 x plus 4. Okay, and that is the fully factored form of that quadratic.